Hello viewers, in today's session we are going to discuss two important and conceptual problem from derivatives, and here we have to find out the derivative of these two functions, that is dy over dx for the first function, that is mod of x times x plus mod of x, and the second one is y is equal to x square over mod of x, right? So here we are going to discuss these two important conceptual problem related to finding out the derivatives of functions involving the important mod function, which is also known as modulus function or absolute value function. So before finding out the derivative of these two functions with respect to x, let us quickly revisit the definition of mod function, because the definition of mod function is going to play an important role in finding out the derivatives of these two functions. So now mod function is defined as a mod of x is equal to positive x whenever x is greater than 0, and mod of x is 0 when x is equal to 0, and mod of x is negative x when x is less than 0, right? So whenever x is a positive quantity, that is x is greater than 0, mod of x is taken as positive x. When x is 0, then mod of x, that is a mod of 0, is 0, and when x is less than 0, it implies that whenever x is a negative quantity, then a mod of x is taken as a negative x, right? Okay, so now I will use this definition to find out the derivatives of these two functions with respect to x. And here we can see that in the first case, the domain of the function is the set of real numbers, right? So here the domain is given by the set of real numbers. So here we can take any x, and this function y is defined, right? But in the second case, we can see that the mod function, it appears in the denominator, right? So here x takes all real numbers except 0. So the domain of the second function is r minus, and here we exclude 0, right? So this function is not defined for x is equal to 0, and this function is defined for all values of real numbers. So now let us redefine these functions with the help of the definition of mod function. So in the first case, we have y, and we'll take first this condition, that is x is greater than 0. Then we'll take x is equal to 0, and then we'll take x is less than 0. So when x is greater than 0, then mod of x is replaced by a positive x, right? So here we have a positive x, then we have x plus positive x, and when x is equal to 0, then mod of x is equal to 0, right? So when x is equal to 0, then this entire term reduces to 0, because mod of 0 is 0 here. So here we can simply write 0, and when x is less than 0, then mod of x is replaced by negative x. So here we have negative x, then we have x plus mod of x. So mod of x can be replaced by a negative x. So now we can simplify. So here we have x, and here we have x plus x. So this is 2x, and here we have x. So we have x times 2x, that is x is greater than 0. and y is equal to 0 when x is equal to 0. And here we have a minus x, and this is x plus minus x, so plus minus minus, so x minus x is 0, so when x is less than 0. So let us rewrite this definition. So we have x times 2x is 2x square when x is greater than 0, and here we have 0 whenever x is equal to 0, and here minus x times 0 is 0 when x is less than 0. So now the definition of this function y is given by this expression, right? So here now if we differentiate y with respect to x, then we have dy over dx is equal to 2 times, here we'll take the derivative of 2x square, and the derivative of x square is 2x. So dy over dx is 2 times the derivative of x square whenever x is greater than 0. And here obviously y is 0, so the derivative is 0. And here also we have 0, so the derivative is 0 when x is less than 0. So now we can further write dy over dx is equal to the derivative of x square is 2x, so 2 times 2x is 4x. So here we have 4x, so the derivative dy over dx is 4x when x is greater than 0, and here we have 0, and here also we have 0. So when x is equal to 0, the derivative is 0. When x is less than 0, the derivative is also equal to 0, right? So the derivative of this function y for these values of x is given by this expression. So now here it is quite interesting to note that suppose we have to find out the derivative of this function y, say at x is equal to uh, 2, right? And 2 is greater than 0. So we'll use this expression because dy over dx is equal to 4x whenever x is greater than 0. So here we'll take x is equal to 2. So this is 4 times 2, that is 8. So the derivative of y at x is equal to 2 is given by 4 times 2, that is 8. So for all positive values of x, we can use this expression, that is dy over dx is equal to 4x to find out the desired derivative, right? Now at x is equal to 0, obviously the derivative is equal to 0. So the derivative is equal to 0. It implies that the tangent to the curve is parallel to the x-axis, because here the slope is equal to 0. So if we denote the slope by m, then m is equal to 0. Now suppose we wish to find out the derivative of the same function y with respect to x at x is equal to say minus 3, right? And minus 3 is less than 0. So here the derivative that is dy over dx is equal to 0 whenever x is less than 0. So here again for all negative values of x, that is x less than 0, the derivative is equal to 0. So now let us consider the second problem. So now let us redefine this function y is equal to x square over mod x with the help of this definition. So we can now write y is equal to, here we have x square over mod x. So when we take this condition, that is x is greater than 0, then a mod of x can be taken as positive x. And since we have already explained that this function, the domain of this function is r minus 0, so here we'll exclude this condition, that is x is equal to 0, since this function is not defined at x is equal to 0. So we'll straight away come to this condition, that is x is less than 0. So when x is less than the 0, then a mod of x is negative x. So we have x square over minus x. So we can now write y is equal to, here x and x get cancelled, so we have simply x, and when x is greater than 0. And here when we cancel this x with this one, then we have simply minus x when x is less than 0. So this is the redefined form of this function. So now let us take the derivative of y. So we have dy over dx is equal to the derivative of x when the condition is x is greater than 0, and here we have the derivative of minus x when the condition is x is less than 0. So we can now write dy over dx is equal to the derivative of x with respect to x is 1. So we have here x greater than 0, and here we have minus 1 when x is less than 0, right? So this is the required derivative of this function y with respect to x. So dy over dx is equal to 1 when x is greater than 0, and dy over dx is minus 1 when x is less than 0. So now let us find out the derivative of this function at, say, x is equal to 5 over 2. Right now here x is equal to 5 over 2, and this is a positive quantity and it is greater than 0. So we'll use this definition, right? So we have dy over dx is equal to 1 whenever x is greater than 0, and here 5 by 2 is greater than 0. And moreover, here we can see that the derivative is independent of x, because dy over dx is equal to 1, right? So the derivative of this function at this point, the notation is this one, that is x is equal to 5 over 2. It is equal to 1 itself, right? So the derivative of this function at x is equal to 5 by 2 is equal to 1. Similarly, if we take x is equal to, say, here 6, then the derivative is again equal to 1 at x is equal to 6, right? Because the derivative is independent of x. Now again, suppose we wish to find out the derivative of this function at x is equal to, say, minus 3, right? So the derivative is dy over dx is equal to minus 1. In this case, we'll utilize this definition. So we have minus 1 whenever x is less than 0. So here minus 3 is less than 0, right? So the derivative at x is equal to minus 3 is equal to minus 1, because this is independent of x, right? So this is how by making use of the definition of mod function, we can find out the derivatives of these kind of functions involving absolute value function. Hello viewers, in today's session we are going to discuss a very conceptual problem from derivatives, right? And here we have to find out the value of the derivative of this function, that is square root of x square minus 4x plus 4 when x is less than 2, right? So let us see how by the use of the concept of mod function, we can find out the derivative of this square root function with respect to x when x is less than 2. So here let us first take this function as a y. So we can take y is equal to square root of x square minus 4x plus 4. And if we closely look at this trinomial, that is x square minus 4x plus 4, then we can write it like this: x square minus 2 times 2 times x, and then we have here for 4 we can write 2 square, right? So now we have this form, that is a square minus 2ab plus b square, where a can be taken as x and b can be taken as 2, right? And this is a famous identity, that is the square of a minus b, right? So we can now write this function y as square root of x minus 2 square, right? So now let us make use of the concept of the definition of mod function, right? Now see, mod function is defined like this, that is square root of say p square can be written as a mod of p, right? And mod of p can further be defined like this, that is a mod of p is positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is negative p when p is less than 0, right? So if we compare square root of p square with this one, then we can see that our p is x minus 2, right? So now if we define mod of x minus 2 using this definition, then we can now write square root of x minus 2 square is equal to mod of x minus 2, and this can be written as positive p. P is x minus 2 whenever x minus 2 is greater than 0, right? So x minus 2 greater than 0 implies x is greater than 2, and mod of x minus 2 is equal to 0 whenever p is 0. So x minus 2 is equal to 0, so this implies x is equal to 2, and mod of x minus 2 is equal to negative of x minus 2 whenever p is less than 0, that is x minus 2 is less than 0, and this implies x is less than 2, right? So we can see that this expression, that is d by dx of square root of x square minus 4x plus 4, can be now written as square root of x minus 2 square, and this can be written as d by dx of mod of x minus 2 using this definition. So now here we are given this condition, that is x is less than 2. So now when x is less than 2, then mod of x minus 2 is equal to negative of x minus 2 when x is less than 2, right? So we can now replace mod of x minus 2 by a negative of x minus 2, because here we are given x less than 2, and mod of x minus 2 is equal to negative of x minus 2 when x is less than 2. So now we have d by dx of minus x plus 2. So multiplying these two terms by minus 1, so we have minus x plus 2. So now the derivative of minus x plus 2 can be written as d by dx of minus x, and then we have d by dx of 2. So here we can take this negative sign in front of this operator d by dx, so we have minus d by dx of x, and here the derivative of a constant function is 0, and the derivative of x with respect to x is 1. So we have here minus 1, right? So the derivative of square root of x square minus 4x plus 4 is equal to minus 1 when x is less than 2. So for all x which are less than 2, the derivative is equal to minus 1.